Welcome everyone to our ARSET training series, Geostationary Remote Sensing of Trace Gases for Air Quality Applications in North America. Today is part one of our training series, North American Geostationary Trace Gas Data Products for Air Quality. My name is Christina Pistone. I am a research scientist at the Bay Area Environmental Research Institute and NASA Ames in the California Bay Area, and I am the ARSET lead for this training. Before we begin today's training, I'm just going to say a quick few words about the ARSET program. The NASA Applied Remote Sensing Training, or ARSET program, provides cost-free training on the use of remote sensing observations, analysis methods, and tools. We provide training in several thematic areas, including agriculture, climate and resilience, disasters, ecological conservation, health and air quality, water resources, and wildland fires. ARSET provides trainings both online or in person. Our online trainings are delivered in two formats, live and instructor-led, like today's training, or asynchronous and self-paced. Like NASA's free and accessible data, all of our trainings are offered at no cost, and we only use no-cost and open-source software and data. We try to offer trainings in more than one language whenever we can, including a planned Spanish version of this training later this year. We offer our trainings at a range of levels, so you can find a training series that will fit your level of experience and need. Please visit us at our website to learn more. We'll start today by giving an overview of this training series, Geostationary Remote Sensing of Trace Gases for Air Quality Applications in North America. The Tropospheric Emissions Monitoring of Pollution, or TEMPO mission, represents a new capability of hourly monitoring of trace gases across North America. It is the first space-based hyperspectral instrument to continuously measure daytime air quality over North America from the Atlantic Ocean to the Pacific and from central Canada to southern Mexico. These data are essential for understanding diurnal changes in air quality and monitoring real-time movement of pollutant plumes, such as wildfire and urban emissions. This training will provide an overview of TEMPO capabilities and available trace gas data products, and will illustrate how TEMPO data can be visualized using the NASA Worldview online tool. TEMPO's capabilities will be demonstrated through hands-on case studies using the TEMPO data, and participants will learn how to interpret the TEMPO observations for understanding of the scope and potential air quality impact of some common scenarios. By the end of this training, attendees will be able to describe the basic characteristics of TEMPO and its benefits and limitations compared to other air quality relevant missions and instruments, identify available trace gas data products from TEMPO and their associated characteristics, visualize hourly TEMPO trace gas data products using NASA Worldview for current and historical events, evaluate TEMPO trace gas products in Worldview to anticipate short-term air quality risks, such as high concentrations of ozone precursors, distinguish uses for TEMPO trace gas data products given cloud and solar zenith angle thresholds, and determine the spatial patterns, temporal trends, and likely sources of trace gases related to wildfire smoke and urban area air pollution events using TEMPO data in Worldview. As a prerequisite to this course, we've recommended that you take our Fundamentals of Remote Sensing training to familiarize yourself with some terminology and concepts that you might hear in today's training. Some examples that are important in today's training include what is meant by spatial and temporal resolution of a sensor, the differences between level 1, level 2, and level 3 of satellite data products, and the characteristics of satellites in geostationary orbit. This training will take place over 2 days. With part 1, which is today, we are covering North American geostationary trace gas data products for air quality. It's offered in 2 sessions at 2 different times, as you can see here. Part 2 will be 2 days from now, covering case studies in trace gas monitoring with North American geostationary sensors at the same times on that day. After part 2, a homework assignment will be posted on the training webpage, and a certificate of completion will be awarded to participants who attend all live sessions and complete the homework assignment before the given due date. And with that, we're going to get into part 1 of this training. First, a brief introduction to who we are. As I said earlier, my name is Dr. Christina Pistone. I am a research scientist at Berry, and with me today is Dr. Erin Nager, the TEMPO Mission Applications Lead at NASA Marshall Space Flight Center. The objectives of part 1 of this training. By the end of this part, attendees will be able to describe the basic characteristics of TEMPO and its benefits and limitations compared to other air quality relevant missions and instruments, identify available trace gas data products from TEMPO and the associated characteristics, distinguish uses for TEMPO trace gas data products given cloud and solar zenith angle thresholds, and be able to visualize hourly TEMPO trace gas data products using NASA Worldview for current and historical events. So brief logistics for how to ask questions. Please feel free to put your questions in the questions box and we will address them at the end of the webinar. You can enter them as we go. We will try to get to all the questions that we can during the Q&A session, but the remainder of the questions will be answered in the Q&A document, which will be posted to the training website about a week after the training. And with that, I will turn it over to Aaron.
All right, well, thank you, Christina, for that introduction. Now we're going to dig into an overview of the TEMPO mission and the instrument and its capabilities. A few slides here. The TEMPO mission, the major goal here is to provide high resolution observations or measurements on air pollutants across greater North America every hour during the daytime. And some of the key objectives here are to deliver revolutionary air quality data to the community and the public, improve air quality forecast and alerts, better understand pollution sources, better inform policy and regulation, and enhance health studies from pollution exposure estimates. To the right, I'm sharing a few of the key products or observations from TEMPO, including nitrogen dioxide, formaldehyde, and total ozone. And those maps are showing also the TEMPO field of regard, as we call it as well, there in red. And at the bottom left, I'm showing a really nice image, a nice picture of our TEMPO instrument when it was completely integrated on our satellite IS-40E prior to launch. A few quick facts on the TEMPO mission. It was NASA's first Earth Venture instrument, selected in 2012, and it's a joint project with the Smithsonian Astrophysical Observatory. It is a hyperspectral ultraviolet visible spectrometer that is sensitive to policy relevant trace gases and aerosols. And to the bottom right here is a figure showing the observation area that TEMPO performs in. So it performs on 2 different detectors in the ultraviolet and visible. So we're seeing these 290 to 490 nanometer wavelength spectrum and 540 to 740 nanometer wavelength spectrum, where TEMPO provides these very high spectral resolution observations to get at key information on these air pollutants shown here. And the TEMPO field of regard covers greater North America. The standard coverage of TEMPO is shown in the black area here. And however, TEMPO is able to go outside those bounds. There's a max field of regard coverage shown here in purple. We've done some tests with moving TEMPO outside the standard domain, but of course our standard normal observations were done within the black area shown there. TEMPO was launched into geostationary Earth orbit on a SpaceX rocket to its current longitude at 91 degrees west on April 7th, 2023. TEMPO's first light or Earth observations were done on August 2nd, 2023. And we had a fairly 6-month about commissioning phase, which was successful and then led into our nominal operations phase of the mission, which we're currently in. And that occurred on October 19th, 2023. And we are currently, our mission is currently funded and extended through September 2026. Of course, TEMPO can be up there 10+ years, depending on funding down the road. So here's a nice picture too of the SpaceX launch, or the TEMPO launch on the SpaceX rocket on April 7th, 2023. So during the pre-launch phase of the mission, we definitely did discuss the core applications of TEMPO with our early adopter community of the mission. And this was a diagram that the science and the early adopter community kind of built during the pre-launch phase of the mission. You can see that the core applications definitely center around air quality, air quality modeling and forecasting, air pollution emissions and monitoring. We have a large number of stakeholders in the air quality management community, and also a pretty long list of early adopters involved in public health applications of TEMPO. Additional application areas include vegetation and ocean monitoring and weather analysis and forecasting. All right, this slide here is showing the TEMPO's footprint size across the TEMPO field of regard. Top figure here is showing the east to west pixel size in kilometers and the north-south pixel size in kilometers. And as we're seeing here, we have very fine TEMPO footprints or high spatial resolution from TEMPO across much of the field of regard. We lose some of that information content as we go farther north in the field of regard, especially in the northwest and northeast corners, but altogether very high spatial resolution. This table to the right shows different locations across the field of regard and the TEMPO footprint size tied to those locations. So key take-home message here is, again, when you go further north in the TEMPO field of regard, like Juneau, Alaska, Canadian oil sands, you have larger footprint sizes. If you go farther south, for example, over Mexico City, we have fine scale pixel sizes. So there are some variations throughout the TEMPO field of regard. And here's a map zoomed in showing the TEMPO footprints by these red boxes here, red polygons, and showing the spatial coverage of TEMPO across the LA area. So you can see we're getting a lot of information content, spatial information on air pollutants across the LA area by having this type of spatial resolution or footprint size across these urban areas. Now zoom into New York City or the broader New York area. And again, getting a lot of different TEMPO footprints that can retrieve information on air pollutants across the New York area and showing how TEMPO can observe these interurban air pollutant gradients. And same picture here over a similar picture here over Mexico City. Of course, we have even higher spatial resolution across Mexico City. So we're really zoomed in here and showing the large number of TEMPO footprints that we're able to, that we have over this region of interest to the south of the field of regard. All right, now we're going to dig into actually showcase some TEMPO data here and look at our how TEMPO performs its scans across the field of regard. This is an example on July 26, 2024, where we had our nominal operations performing, and this is TEMPO tropospheric NO2 data shown in this animation, where we're seeing how these nominal operations consist of both the standard hourly daytime scans, where we're gathering data across the entire field of regard, and also these optimized shorter scans that we're seeing here later in the afternoon across the west. So we see the same picture here across the east in the morning, where we have only daylight in that region. So we're performing the TEMPO operations in that region, the optimized scans. Then we move to the standard operations and then back to the optimized operations in the west in the afternoon. So that's kind of the day in the life of TEMPO in terms of making its observations. And we also had a special component of TEMPO where we can zoom in to areas of interest and perform TEMPO special operations. So this was a 4-day time period from January 16th and 19th, 2025, where we performed these very high resolution 10-minute scans across the west coast of the US, and then went back and forth between our nominal hourly operations and our special operations throughout the day, and with this for a 4-day time period. So this is another really unique component of TEMPO as well. This was done right after the large LA wildfires that occurred in January 2025. So if we zoom in to that LA basin area, and this is kind of when the wildfires kind of died down, but they're still smoldering from the wildfires. And this animation to the left is showing the tropospheric NO2 that was collected during those special operations and the high variability in NO2 columns that were observed across the LA basin region. And when taking a look at the time series information here for 2 days from January 16th through 17th, and taking a location of interest within the location of the Palisades wildfire, we're seeing how during this smoldering time period of the wildfire event, we're capturing this NO2 diurnal variability, which is not quite captured by the standard normal observations shown here in black. So the blue line here, blue dots are showing the addition of the special operations over the region compared to the normal standard observations. Now down here to the bottom right, we're showing an area in downtown LA where, again, we observed the stronger variability and NO2 variability in downtown Los Angeles during the morning of January 17th, which was not captured by our tempo standard scans. So again, the addition of the special scans helped collect more information on NO2. And you can actually go to our tempo operations log through this QR code here and find the days when these special operations occurred. And here's a screen capture of part of that operations log and where the special operations that were done for the LA region from January 16th through 19th were done. So you can kind of find that in the operations log along with the other special operations that we've done to date. All right, so now we're going to discuss a little more detail on the tempo trace gas products in the following slides. And first showcase how tempo observes these trace gas pollutants that we provide from the mission. And the key variable, the key input here is the ultraviolet to visible radiation from the sun. Tempo requires sunlight to make observations of these trace gas pollutants, and which then we observe these top of atmosphere radiance shown here in this diagram, and along with our retrieved slant column density information. And we combine that with sun and satellite viewing condition information to report or retrieve information on vertical column densities, which are really the VCDs here provide information on the target trace gas of interest within a standardized vertical column of the atmosphere. So we're saying this is our key output and our key parameter that we provide in our tempo trace gas products. And how we do that, going from our slant column to our vertical column information or data in the tempo retrieval process, is done by first deriving our slant column densities from our measured top of atmosphere radiances that were shown in that previous diagram. And then we calculate vertical column densities using air mass factors. And these air mass factors are calculated offline using an array of transfer model and input from a global 3D atmospheric composition model. And tempo in particular uses the Goddard Earth Observing System composition forecasting system to put together these air mass factors. And this equation shown to the left is showing the equation where we have slant column densities in the numerator and this air mass factor variable, which actually combines a large number of information in the denominator, which then derives or retrieves information on our vertical column densities. And shown at the bottom of the slide here are the NO2 slant column densities, zoomed into the Pacific Northwest here, and our NO2 air mass factors in the middle, and our total NO2 vertical column densities on the right. The key message here is that you can see how our slant column densities of NO2 are higher than our total NO2 VCDs. And that shows how this process from going from our slant column density to our vertical column density leads to lower VCDs as we're looking at the vertical column directly above the tempo footprint compared to the slant column information that's shown here. And we also go a bit further with our tempo retrieval to derive tropospheric NO2 VCDs. So here is a comparison between our tropospheric NO2 vertical column densities and our total NO2. And as expected, our tropospheric NO2 VCDs are lower than our total column NO2 VCDs. And there was a wildfire that occurred during this time period, So this large NO2 plume in this map is tied to a large wildfire smoke event that occurred in North California. Now we go a bit to do this whole operation where we derive tropospheric NO2 VCDs. We apply a stratosphere-troposphere separation technique in our tempo retrieval process. And this method estimates the stratospheric NO2 VCDs based on the slant column densities, the air mass factors, and the NO2 columns from the GeoCF forecast. The stratospheric NO2 VCDs are then subtracted from the total column NO2 VCDs to arrive at our tropospheric NO2. So, and note the different scale on these figures here, but to the left here, again, I'm sharing the total NO2 VCD map. Here's our stratospheric NO2 VCDs. Again, lower scale here, much lower NO2 in the stratosphere in general. And then to the right, I'm showing the tropospheric NO2 VCDs. So you can see here how we have these lower tropospheric column amounts compared to our total, and how we go from our total to our tropospheric. And there's also quality assurance variables within the data files of tempo, which I'll go over here in a minute, to where we can filter lower quality or higher uncertain data. And here is where I applied a filter where we only kept data with a cloud fraction of less than 50% and a solar zenith angle less than 80 degrees. And going back and forth, you can see how we end up having these areas where clouds are removed, but also areas where even the smoke plume were removed, which I'll go into a bit more detail of another use case of when that happens. All right, so for the tempo, this is a table showing the tempo data products, the baseline, the near real time, and also the upcoming NOAA aerosol products. And we start with the level 1 data, the level 1 radiance data, which is at this tempo footprint size of 2 by 4.75 kilometers squared, which is the tempo footprint size at the center of the field of regard. But as we saw earlier, that footprint size varies throughout the tempo field of regard. Then we derive or retrieve these various products shown here, including cloud products, ozone total column, nitrogen dioxide, formaldehyde, and ozone profile. Some of these are also near real-time products. So we are currently providing near real-time products with data latency of less than 2 hours. And that includes our cloud, nitrogen dioxide, and formaldehyde data. And a key point with our ozone profile is the ozone profile provides information on tropospheric ozone column amount. So we get that information in the troposphere and lower troposphere, and we can actually track ozone concentrations really well in the troposphere through the ozone profile. Upcoming products in the near future are going to be our aerosol products, including aerosol optical depth and aerosol layer height, and an aerosol detection product. Those level 2 products shown here, the baseline products also have a level 3 product tied to them, which are pretty much very similar to our level 2, except they are put on a regular standard 0.02 degree grid across the tempo field of regard. So those grid point sizes don't change like the footprint sizes do up here. I do want to note that the ozone profile level 3 is a bit coarser at 0.04 degrees compared to the other level 3 products. And the reason for that is, as you can see here, the resolution of our ozone profile for level 2 is coarser because there's some co-adding or averaging done of pixels to make that product of higher accuracy precision for the community, which is required. And finally, we have level 4 products, which will include our surface PM 2.5 product with an hourly PM 2.5 estimation. Okay, now we're going to do a little more discussion on level 2 versus level 3 products from tempo. Kicking off here is the general methodology where we go from our tempo level 2 products to our level 3. And the level 3 products are essentially created from regridding level 2 data onto a regular grid using an area weighted averaging approach. So we do that at the 0.02 degree grid for NO2, formaldehyde, and total ozone. and at that 0.04 degree grid for ozone profile. The equation that is used here is shown on the slide, and it's really just geometric regridding, where we take contributions from nearby grid points that overlap that level 2 pixel footprint, and then apply this equation to get at our level 3 data for each grid point. And here's an example of the level 2 versus level 3 data zoomed into the LA Basin area on June 18th, 2025, zoomed in on LA Basin and showing the comparison between level 2 and level 3. So we're seeing those kind of polygon shapes when we look at our level 2, which was shown on that map earlier, the tempo footprints, and now we have this like standard regular grid that we're seeing this tempo data appear in the level 3 product. So this is in the morning hours where we have high NO2 likely tied to the traffic in the morning across the LA Basin area. So for our level 2 data, we provide these in different data granules across the tempo field regard. There's 9 different level 2 data granules that compose each full tempo field regard scan during our hourly standard operations. So we're seeing this for this is simply just an animation showing 1 hour of those 9 different 6 to 7 minute data granules that are provided across the tempo field regard. And note this did change before starting September 29th, 2023, we went from 10 to 9. So during the commissioning phase, we had a little larger number before September 29th. All right, so then we take those 9 different tempo data granules for each full tempo field regard scan and compose a level 3 scan data file. This is similar to the previous or same time frame as a previous animation, but just taking all those level 2 data granules, stitching them together, and doing that remapping, regridding process to put that NO2 data on a 0.02 degree grid across the tempo field regard. This is how those level 3 scan data files are provided for tempo. And zooming in here to the LA Basin again, looking at the level 2 versus level 3 NO2 comparison for a morning, early afternoon, and late afternoon, evening timeframe during this one day on June 18th, 2025. And we're seeing similar information as before in terms of, you can really see the polygon shapes where these NO2 column data are shown, and then kind of the regular grid shown here. Kind of one key take home here is in general, level 3 NO2 maps or data will have a smoother appearance compared to the level 2 NO2 maps after doing that regridding averaging process. And this can also lead to some significant differences in like fine scale NO2 hotspots and large NO2 gradients when you're comparing the level 2 and level 3 data and maps. This is same kind of comparison here, except for formaldehyde. So we're going from level 2 to level 3 formaldehyde comparison. Formaldehyde is a noisier, more difficult retrieval compared to NO2. So in general, that just makes this comparison a bit harder in terms of seeing where all these gradients or differences are occurring. But again, similar thing here where we have a smoother appearance to our level 3 formaldehyde map due to that remapping and regridding process compared to our level 2. All right, so now we want to talk a little bit more in detail about the quality assurance and data filtering methods, which are really needed by the user community. And our recommendations here are based on the latest recommendations for the version 4 product release. It's important to note here that we went from version 3 to version 4 data. Version 4 data started being produced on September 17th, 2025. We haven't reprocessed the data prior to September 17th, 2025 yet, but for now, all our version 4 data are available starting September 17th, 2025. So these recommendations here are focused on that version 4 data, and this table is showing the key quality assurance parameters that are recommended for use. And this includes effective cloud fraction, solar zenith angle, and our main data quality flag. This quality flag is a bit more complicated in terms of how, what these flags refer to in the product, in the variable. And for example, a flag of 0 means high quality tempo retrieval. A flag of 1 means suspect retrieval due to air mass factor or viewing geometry issues. And a flag of 2 means outlier retrieval, or there is no successful air mass factor calculation. So for looking at the different ranges of these variables, we have the effective cloud fraction ranging from 0 to 1, solar zenith angle, as you'd expect, from 0 to 90 degrees, and our main data quality flag going from 0 to 2. Currently in Worldview, for all the available version 3 data that are available to view, these are the qualitative use thresholds that are applied. So they apply a cloud fraction of less than 0.5, solar zenith angle less than 80, and a main data quality flag less than 2. For quantitative use and research use, there are different recommendations in our tempo user guides. So they recommend a much lower cloud fraction threshold of less than 0.1 to retain high quality data. That can kind of vary, 0.2, 0.15, depending on your application, of course. Solar zenith angle is less than 70 degrees for quantitative use, and they recommend only retaining the high quality tempo retrievals for quantitative research use as well. All right, so this is an example of comparing those quality assurance thresholds and the different maps that can be shown based on those different assurance thresholds. So this is for one day on September 20th, 2025. Zoomed into the Pacific Northwest here of tempo tropospheric NO2. And we're seeing here at the bottom are those stricter quality assurance recommendations shown on the previous table. These are the thresholds at the top here are those currently used for the Worldview NO2 visualizations. And the key message here is that there were some cloud cover during this time period, and we're seeing more white masked out areas in the lower panels here due to cloud cover, but also we're seeing a wildfire event that occurred during this time period. So there was a pretty large wildfire, and we're seeing very high NO2 plume tied to that smoke. But when we apply that cloud fraction, the strict cloud fraction quality assurance threshold, we remove that smoke plume, the NO2 plume from the map and analysis. So, care needs to be taken when applying these cloud fraction thresholds based on your application and needs. And looking at the similar thing here, but looking at solar zenith angle quality assurance. And this is using the strict cloud fraction of 10%, but then looking at the solar zenith angle of 80 degrees versus 70 degrees. So when we apply that stricter solar zenith angle threshold during the morning and late afternoon here, we can see that we lose information content on NO2 based on that updated more strict solar zenith angle in these maps here. And to the right, we're looking at the whole entire tempo field of regard here, applying the less strict cloud fraction, but the main change here was looking at a flag of equal to 0 versus a flag of less than 2. And by using a flag equal to 0, we lose this tropospheric NO2 information in the far northwest and far northeast due to the viewing angle restriction flag within the product. So it's another thing to keep in mind when using the flag variables within the tempo NO2 and formaldehyde data. And I wanted to share another table here for the quality assurance recommendations for tempo total column ozone. Slightly different, but similar to a degree. We have quality flag parameters, effective cloud fraction, solar zenith angle, viewing zenith angle recommendations. There's a lot more information contained within the quality flag here compared to NO2 and formaldehyde, including sun glint contamination and SO2 being present. You can kind of see the different ranges, much higher range with this quality flag. For qualitative use, they recommend less than 1024 for the quality flag, and for quantitative use for total column ozone, for best highest quality data, is simply apply the flag equals 0. And if you want to retain more adequate data, you can also keep those flags equal to 1, 2, and 5. Effective cloud fraction, there's no filter currently being used for qualitative use in Worldview. However, for quantitative use and research, they recommend an effective cloud fraction of less than 0.5. And you're seeing similar solar and viewing zenith angle quantitative use restrictions for our total ozone column as shown for NO2 and formaldehyde. And now we're comparing the different quality assurance thresholds shown here, same day on September 20th, 2025, as shown for NO2, but this is for total column ozone, and applying the qualitative thresholds that were shown in the previous slide and the more quantitative research thresholds. So as we would expect when applying a cloud fraction on the bottom panels here, we're seeing more areas removed due to cloud. Also, there is some influence from applying that quality flag equal to 0 as well. Some of these areas around here were also removed due to that quality flag. So again, take into account kind of what happens going from our different qualitative to quantitative thresholding for this product. All right, so now we're zooming out and looking at the tempo field of regard for total column ozone. And at the top here, we are looking at the quantitative, more research thresholds versus the qualitative thresholds that were shown on the previous slide. And as you can see, when we apply that stricter cloud fraction, we remove the clouds from the scene, but also there's some influence from that quality flag equal to 0. You can especially see that quality flag equals 0 and the sunglint contamination removed from the far south extent here. This is sunglint. That's removed when we apply that quality flag equal to 0 versus retaining that sunglint area in the bottom map. And there's also some influence from applying that quality flag in other areas of the field of regard as well. Okay, now we're going to actually show some examples of our level 2 trace gas products. And for this example, we're going to be focused on that version 4 data time period. This is zoomed in to the South US on October 15th, 2025. To the left here, we're showing a Beer's true color image, and on the right, showing the animation of tempo tropospheric NO2 vertical column densities on this one day from morning to evening across the domain. And what we're seeing here are high NO2 BCD columns over Dallas, Houston. We're seeing some elevated NO2 across the major traffic corridors and over the Permian Basin as well. So there's a large oil and gas infrastructure and across the Permian Basin. And we're seeing some higher NO2 columns tied to that Permian Basin, along with some small hotspots of NO2 tied to power plant locations, and also some fires that were occurring across the domain, across the east here especially. We had some fires that were occurring across Louisiana, for example. And some of these NO2 hotspots were tied to those fires. And then this is another animation for total column formaldehyde. So same day, October 15th, 2025, morning to evening formaldehyde information across the South US. And one of the areas of higher formaldehyde concentrations, if you look at this animation closely, occurs over the Houston area. So that is a typical urban area tied to high formaldehyde concentrations. So we see that in our formaldehyde animation here, along with other areas of elevated formaldehyde, even over the Permian Basin, tied to the NO2 in that region and the oil and gas industry. And this is animation for total column ozone for the same day. And again, this is total column, so this takes into account both the troposphere and the stratosphere. Over 90% on average of the ozone is contained within the stratosphere. That being said, we're still seeing some variations in total column ozone in this animation, with some higher concentrations across various regions, including in and around the Houston area. Of course, now we have our tempo ozone profile data, which is shown here. This is the tempo tropospheric ozone column data for that same day. And now we're seeing some stronger, more apparent distinct variations in our tropospheric ozone column amounts as we retrieve this information only in the troposphere. And I'll highlight again one of the areas of interest over the Houston area, as we see these higher ozone concentrations that occur in the later afternoon area during that animation. We can even get down to the lower troposphere with our tempo ozone profile product. So same day, but looking at the 0 to 2 kilometer ozone column information. And this is really neat what we see here. We'll replay the animation again from morning to evening. And as you will see in the later afternoon, evening hour, we see a definitely distinct high values that are occurring in and around the Houston area, mainly to the southwest, where the ground monitors observed higher ozone columns, higher ozone concentrations on this day as well. So really neat that we're picking out some of the elevated lower tropospheric ozone in the area where the ground monitors measured higher ozone concentrations and unhealthy ozone levels. So we're changing days here to September 26, 2025, because we had a large wildfire event occur on this day. So again, to the left, I'm sharing the VIIRS True Color image here in the Pacific Northwest, and we're seeing these large grayish color intensities here tied to wildfire smoke on this day. And to the right, we're looking at the tempo ultraviolet aerosol index, and this variable is contained within the tempo total ozone product. So what's really neat about this is we see these higher UV aerosol index values tied to these wildfire smoke plumes, and that's due to the absorbing nature of smoke particles. So which leads to the high UV aerosol index value. So this parameter can be very useful in terms of monitoring and tracking smoke plumes throughout the day. Okay, so I did want to share some comparisons between tempo and our current low Earth observing satellite instruments, the NASA Ozone Monitoring Instrument, and TROPOMI. All these results here are based on our version 3 tempo products. So this is the comparison between our low Earth orbiting ozone monitoring instrument versus tempo. Again, OMI is a low Earth orbiting, so it only provides midday observations of air pollutants across the globe. And its spatial resolution is much coarser at 13 by 24 kilometers squared compared to what we have with tempo. And this is showing just a zoomed out, over the west region of the US, OMI tropospheric NO2 versus tempo. And it is, you can see the really incredible information content that we get from tempo NO2 compared to TROPOMI. And if we zoom in, look at the zoomed in images over the LA Basin area versus tempo versus OMI, we can see that tempo NO2 tropospheric vertical column densities are larger than OMI in urban areas, and this shows over the LA area, over Mexicali too, and this is a combination of both the much higher spatial resolution of tempo that's able to capture these areas of high NO2, but also the higher instrument sensitivity of tempo as well. So this is really incredible now what we're seeing with tempo compared to our previous legacy instruments like OMI. Okay, now we're looking at a comparison between tempo and tropomi. So tropomi, like OMI, is a low Earth orbiting satellite instrument. It was launched in 2017 and provides higher spatial resolution information than OMI. So now tropomi is providing NO2 observations at 5.5 by 3.5 kilometers squared. So we can definitely see right away that the comparison between tropomi and OMI is much closer than OMI and tempo. Number one, there are differences for sure tied to the different instrument retrieval techniques, but also the spatial resolution as well. So if we can kind of see that, if we zoom in closer to the tempo versus tropomi comparison across the LA basin area here, where we are seeing, in general, higher NO2, tropospheric NO2 from tempo across the LA basin. Again, this likely has to do with both the different instrument retrieval techniques, but also in general, the higher spatial resolution of tempo is contributing to these different NO2 differences. But it is important to note that we're still capturing similar NO2 gradients, tempo versus tropomi. There's just differences in the values here. Okay, now we're going to dig into a little more quantitative comparison between tempo and tropomi NO2 at these selected areas across the field of regard, shown here in the map in the top right. Key take-home points here is that tempo is higher than tropomi at these locations of interest in general. Tempo tends to be a little bit lower than tropomi in non-attainment areas. Tropomi tends to have a high bias in these low NO2 conditions. And if we do more of a detailed comparison between tempo, tropospheric NO2, and tropomi at the Boulder and the LA South Coast locations here, we're seeing that we're getting better correlations between tempo and tropomi across the Boulder area compared to the LA South Coast area. So we're having correlations of 0.73 in Boulder and correlations of 0.36 across the LA South Coast. So the main take home here is that tempo and tropomi, they generally are in agreement, but they can also be, their comparisons can vary at different locations across the field of regard as well. Okay, so now we're going to do a little more in detail with the validation of tempo products. This is again a validation comparison done for our version 3 tempo products. And this is a comparison tempo validation done against our Pandora network. So our Pandora is our main ground-based validation network for tempo. And Pandora provides NO2 and formaldehyde observations or measurements like tempo, but from the ground-based perspective. And here we're showing the correlations and mean biases between tempo NO2 and Pandora, and tempo formaldehyde and Pandora formaldehyde. And the key take-home notes are that tempo NO2 in general reproduces the spatial variability of Pandora. It correlates well at most of the Pandora sites. And for tempo formaldehyde, we have similar outcomes here with fairly high correlation at the Pandora site level. There is some reasonable bias with some of the individual sites that are requiring further investigation, which we're currently doing. This validation work is ongoing with our version 4 data as well. So more to come in terms of our tempo validation versus Pandora for our version 4 data. But in general, our tempo version 3 data showed good comparisons between our Pandora observations of NO2 and formaldehyde. And if we go into looking at tempo versus Pandora, taking account all those sites that we just showed in the previous slide, and look at the per month comparisons and variability. This is showing tempo versus Pandora NO2 at the top, and for formaldehyde at the bottom. And for both of these comparisons and figures, we are showing that tempo NO2 and formaldehyde captures the seasonal variations well, with pretty good bias as well, low bias. So this is showing again that tempo is able to capture these seasonal variations as shown by Pandora. And we can get into more detail in terms of the variations per day, per hour of the day. Same as before, but looking at tempo versus Pandora, NO2 at the top and formaldehyde at the bottom for different time periods throughout the day for all those sites that we saw. So one of the key messages here is that the NO2 for tempo during the time periods in the morning and the evening with higher solar zenith angles, we see a lower correlation, but still good correlation between tempo and Pandora. This is expected. We know that our tempo retrievals have lower accuracy during the morning and the evening. It's not as apparent in the formaldehyde. When you're looking at the formaldehyde comparison between tempo and Pandora throughout the day, our correlations are in general lower than NO2, and that's to be expected because the formaldehyde retrieval is more difficult from both the tempo and Pandora perspective. So, but it's great that we're seeing these overall good correlations in general with formaldehyde as well. Okay, now we're going to go into some tempo data visualization and Worldview, and Christina will take it over from here.
Thanks, Aaron, for a great overview of tempo. Now we're going to get into some of the data exploration that you can do with the tempo that are available on the NASA Worldview. So we are just going to go to NASA Worldview from a normal web browser. You can type it in. It's worldview.earthdata.nasa.gov. You can see I've typed that and it's already populated. So when you go to Worldview, this is the landing page that you'll see. Worldview has some great stories to peruse the different data sets that they have here. I encourage you to check these out at a later date. Many of them are relevant to air quality topics, but we're not doing that today. So we're just going to X out this welcome page. And I should note, you are welcome to follow along with what we're doing here, but this is also a recording, so you can go back, you can follow it through later as well at your own pace, pause it and everything. Some of the homework questions are going to involve similar examples, so that will be another opportunity to go through these tools on your own. So we are going to go to explore in more detail the wildfires of January 2025 in the LA area. To orient you a little bit to Worldview, down here at the bottom left, we can see it has defaulted to the current date, 2026, January 12th. Since we're going to go into the LA area, I'm just going to use my cursor scroll wheel to scroll into roughly the California area. For those who may not be most familiar, we're just going to put on some place labels for orientation. And because we're going to January, oh, that's the wrong way. Because we are going to January 2025, I'm just going to click this arrow down. So now it's 2026, 2025. And we are going to go to January 9th of 2025. And again, for some quick orientation here, this is the LA area. We can see that the fires were already in process. The images that show up now are true color images, and they're represented as base layers. So it has defaulted to Terra Modis, and that's what we're seeing here. So it has more of a morning overpass. We can turn off this layer. We can turn on the Aqua Modis. We can see that it had a little bit of a different view later in the day. Or if we want to do a NOAA 20 Veers, we can see that this was a little bit more in the middle of the we can see it was a little bit more in the middle of the satellite swath for this particular time. But what we're interested in today is the tempo data. So we are going to go to this red button down here, the plus add layers. We're going to click on it. And it brings up this page, which has, again, a number of topics. Feel free to peruse them at your own leisure. We have some air quality topics, some specific air quality topics like fires, dust, ash, etc. But since we are going to tempo, what we're going to go is we're going to go to this top search bar and type in tempo. And as we do that, we can see that a number of different products show up. So these are all of the products for tempo, which are currently available in Worldview. So we can click on formaldehyde and it'll give you an idea of the temporal coverage, a little bit of the metadata. We want to explore all of these. So we're just going to click the little checkbox here, and you can see behind this panel that I'm in right now, these data sets are slowly populating underneath here. You can see it's a little bit above this formaldehyde here. So if I were to turn off the formaldehyde, we can see that the nitrogen dioxide is adding itself to the list of variables, the layers that we're going to have available for this particular data. And as you can see, sometimes it can be a little bit tedious to do all of these things, to check all of these boxes. So we are just going to go to a window where I've already had all of these loaded. So we're just going to pull the cake out of the oven already done. One thing again to note, so now we have all of the tempo layers loaded and they are hidden. So we will go through and look at them one at a time. So I've hidden all of those. And another thing to note, for when we first opened Worldview, we had year, month, day, you'll remember. You'll notice since we included the tempo layers, we're now having hour and minute, and this is in time of UTC. And there's also this little increment feature here. It is defaulted to 6 minutes because the tempo revisit time is hourly. We're just going to click on this. When we click on these arrows, it's going to be an hourly time step. So first here, what we're going to do is look at the nitrogen dioxide, since Erin showed some great examples there. So we're just going to click on this level 3 layer. And what are we seeing here? This may be something that will happen as you're exploring Worldview. You can see that the values here are fairly uniform. As I'm mousing my cursor over the map, you can see on the left-hand panel, there's a little triangle and line that's giving you an idea what the numerical values are. They're fairly uniform values. What has happened here, and you might encounter this, we have perhaps inadvertently put on the stratosphere level 3 layer. So this is nitrogen dioxide level 3 vertical column stratosphere, which is not maybe necessarily what we want to do if we are looking at the air quality issues. So now we are looking at nitrogen dioxide level 3 vertical column, tropospheric, and subdaily. This is a little more what we would expect as we're looking at nitrogen dioxide near surface values. And again, we can use the cursor to mouse over the areas of very high concentrations. You can see the values here, almost 3 times 10 to the 16th molecules per centimeter squared. If we move the cursor out towards the ocean where it's a little bit more pristine or uncontaminated, we can see that the values get much lower. We can see, again, some other values from general other sources of pollution in the San Francisco Bay Area and the Central Valley of California. So we're seeing different sources in addition to the very strong smoke plume that we're seeing in the LA area. So now we're going to use these arrows that we set up to increment hourly. And as we do that, we're seeing, again, the bar down at the bottom. You can see it's stepping by an hour at a time. And we can see that the values are also changing. So we're able to see the different time steps that are going on throughout the course of this day, looking at the scene and looking at the values that we're observing here. What has happened here, we have gone to January 10th at 12:45 a.m. UTC. This corresponds to 4:45 p.m. local California time, which is after sunset at this time. So you'll remember tempo is only available during daylight hours, and it's a little bit difficult to see. But if you look on this cursor, if you look on the time bar here, there's a little bit of a different shading from the nighttime values here. So it's a little bit darker. And then there's a change where this is showing where the values are, the data are available over the course of the daytime. So that can give you a sense of where data are available from this instrument for this particular time. So we can step backwards in time again. So now we've reset to sort of the beginning of the day. Okay, so that is nitrogen dioxide level 3 data. We can also look at the NO2 level 2 data. And again, we're picking the tropospheric values. As we turn off this layer, the tropospheric level 3 data, and turn on the level 2 data, you can see this is how that looks. As Aaron mentioned, this is the level 2 data are presented in this way. One thing that you can do, there's a little tool here called View Options. If we click on these little slider options, we're going to increase the granule count here from its default of 1 to 9, because again, there's 9 granules in the tempo overpass. And so now we have the full US one snapshot of tempo is visible at a time. And we can see if we mouse over these, it's giving us a little bit more specific time step for this swath, 1645, 1638, 1631. So these are in approximately 6-minute intervals, going from starting at the earliest time, 1552, as it progresses from east to west across the US. So we can see that the level 2 data are visualized a little bit differently here. Again, we can step through and see the evolution of the scene over the course of the day. To give a sense of the differences between level 3 and level 2 data, this is just a comparison mode. We're going to talk about this more on day 2. Here we're comparing the level 3 data on the left and the level 2 data on the right. And if we drag the slider, this is the level 2 data and the level 3 data. And you'll remember, as Aaron described, the native grid of tempo in the level 2 data are a little bit more of an angled grid, whereas the level 3 data are averaged over 0.02 degree grids. So it's a little bit more regular. This is a way to sort of visualize a little bit the differences between the two, between level 2 versus level 3. So that's the NO2 level 2 data. We can also look at the ozone column values. So we can only look at the ozone total column, but let's see what we have. This is the ozone level 3 column values. Again, if we mouse into different places of the map, we can see that the values on the color bar to the left are changing with the different values, to giving you a sense of the numerical values that we're looking at here. The main takeaway here with the ozone total column is it's very difficult to see any signal from the wildfire event that we know is happening in the troposphere in the column values. So that's ozone. We can again hide that layer. And now let's look at formaldehyde. And looking at formaldehyde, it is similar to what we saw in the nitrogen dioxide. We're seeing a clear plume, a very distinct plume associated with the wildfire smoke that we know is happening as it goes from beginning of the day. We can sort of step through hour by hour and see the changes, the evolution in the scene and the values that we're seeing in formaldehyde over the course of the day and as it disperses off the coast. And again, we can mouse over and get a sense of the quantitative values that are within this plume as well. And finally, what we're going to look at, we're going to briefly look at the aerosol index, which Aaron mentioned as well. It's retrieved in conjunction with the ozone product here. And higher aerosol index indicates the presence of absorbing aerosols, so such as dark smoke in this scene, which we certainly can tell is happening here. So going to the beginning of the day, we can see that detection of absorbing particles is present in this plume as it was observed by tempo as it evolves over the course of the day. So that's the aerosol index as well. So one final thing that we can look at for this event, as Aaron mentioned, there were special operations, every 10-minute observations that were happening a few days later during this same event. And so here is the custom interval selector. One thing we're going to do, because they were every 10 minutes, currently we've had it set to be every hour. We're going to go to custom and do intervals of every 10 minutes. And so now our increment is going to be every 10 minutes. The special operations happened on January 16th and 17th. So we're just going to navigate to the 16th and let's start at 8 o'clock Zulu. And then we are going to look at the NO2 level 2 tropospheric values here. So we'll turn on that layer. And then because we're looking at special operations, we are going to go back into our tools and reduce the granule count. So we're only looking at, let's say, 2 at a time. So now we're only looking at 2 granules at a time. So we can X this out. And so now we are looking at January 16th, 8 o'clock Zulu, which is noon Pacific Standard Time. And we are seeing there are 2 overpasses here, or 2 swaths here, 1954, 1959. If we increment another 10 minutes, now we're seeing 2004, 2009. As we step through the time incrementer of every 10 minutes, we can see how the scene evolves over the course of this day at this 10-minute resolution, where we have the high revisit time, high temporal observations during this particular hour. So I encourage you to go to the tempo log and see if there were any other special operations that may have happened at scenes of interest. So that concludes our visualization exercise in Worldview for today. We will be back in Worldview on day 2 to explore a couple more case studies that we can observe with these data that are available. There are also some other tools that you may want to explore for visualization of tempo data. The slides will be available on the website after the training is done. So here are some other tools that you may be interested in. So this is the conclusion of our part 1 tempo geostationary trace gas training. To summarize what we went over today, tempo's hyperspectral capability enables us to retrieve criteria trace gas pollutants in the troposphere at unprecedented spatial and temporal resolution across greater North America. It allows us to observe small-scale emission sources and fine-scale pollutant gradients that have not been adequately resolved by prior satellite missions. The geostationary nature of its observations allow for monitoring of rapidly evolving pollutants, which support air quality analysis and forecasting. The Nitrogen dioxide and formaldehyde products show overall good agreement to the Pandora validation network and TROPOME satellite data. The ozone profile product, which is currently in beta, will offer enhanced capabilities to monitor and characterize ozone concentrations within the troposphere. NASA Worldview applies tempo quality assurance, which is suitable for qualitative visualization. For more quantitative analysis, users will need to apply quality assurance variables to both level 2 and level 3 products, which remove the tempo data with larger errors or uncertainties from that analysis. With the caution that using strict quality assurance tends to remove large nitrogen dioxide columns from wildfire smoke. To look ahead to our part 2, which again will happen in 2 days. In part 2, we will evaluate the tempo trace gas products in Worldview to anticipate short-term air quality risks, such as high concentrations of ozone precursors. And we will determine the spatial patterns, temporal trends, and likely sources of trace gases related to wildfire smoke and urban air pollution events using tempo data in Worldview. And we will look at 2 case studies, one on some fires in the Colorado Front Range, and then urban air quality conditions and pollution sources over East Texas. As a quick reminder, this training series will have 1 homework assignment. You will be able to access the homework assignment from the training webpage starting January 22nd after part 2, and answers should be submitted via Google Forms within 2 weeks, so by February 5th. Certificates of completion will be issued to participants who attend all of the live trainings and submit the homework before that deadline. The certificates will be issued via email about 2 months after the training. Here we've included the contact information for the speakers today, as well as links to the ARSET website and YouTube channel. We encourage you to sign up for our mailing list. Here are some additional links and resources. Thank you for attending today. We're now going to transition to the Q&A portion of the session. Okay, we've been getting some Q&A already coming into the WebEx. Anybody who has questions, there should be a Q&A box to the bottom right of the WebEx. Feel free to put your questions in that chat and we will try to get to them. So question 1, I guess let's start there. Can you explain why tempo is using a continuous UV visible spectrum instead of discrete bands like other satellites? Aaron, do you want to elaborate a little bit on that?
Yeah, hopefully you can hear me okay.
Yep, sound great to me.
All right, great. Yeah, so tempo is uses a spectrometer that has very fine spectral resolution across that UV visible spectrum. So that's very critical in terms of detecting that very fine absorption spectrum and the differences in the absorption between those critical trace gases that tempo was designed to provide to the community. So that's really the key part, and that really goes even further with the ozone concentrations, because the UV vis spectrometer does also enable improved sensitivity to ozone in the troposphere layer. So compared to using discrete bands like other satellites. So in general and overall, the UV vis spectrometer provides that higher precision and improved sensitivity to trace gases compared to using a satellite with discrete bands, for example. Hopefully that clears things up.
Thanks. Yeah, and to remind everyone, this Q&A document will be posted on the training webpage after the fact as well. So you'll be able to go back over these. So question 2 is regarding the special scans. So basically, I think this is what happens when the special scans are happening. Is there a special instrument, or how do the special scans affect the standard scans that are going on?
Do you want me to go for that one?
Sure.
Okay. Yeah, so I think you kind of answered it there on the document here, but yeah, so we're always There's no special, no separate special instrument. It's all the tempo spectrometer that does the special versus the standard scans, right? So we just transition the tempo instrument from performing the standard, normal, hourly, daylight operations to a special scan mode during a day, right? So you saw that example in the art training where we did that same kind of special scan operation for a 4-day time period. So, we can do that too, where we set the special scan mode to operate for 4 continuous days and then have those 10-minute, for example, 10-minute scans over a certain portion of the field of our guard, happening for that 4-day time period during the daylight.
Yeah, and in the slides, I'll also mention in the slides, there's a link to the tempo operations log, which can give a record of when special scans were happening. And so if there's data missing, it could in a particular time, it could be because there was a special scan happening at in a different time and place, or in a different place during the same time rather. We're getting a number of questions. I'll just combine them all together. There's a number of questions about the stratospheric tropospheric division and how that process is done and how that distinction is made. Aaron, do you want to talk a little bit more about that in sort of a general term? I think I'm combining a bunch of these questions, but they're all similarly themed.
Yeah, I did notice there's a handful of questions related to that. So what we really do is we actually use the total column, right? And we subtract out the tropospheric column. So really, we're not retrieving information directly on the stratospheric portion of that. We have tempo provides the total column information directly. We use then a retrieval process to get at the tropospheric column amount. And after that, we're able to at least get an idea on the stratospheric portion. That's how it's separated out in the tempo data product as well. For NO2, for example, you can get information on the total column, the tropospheric column, and the stratospheric column portion within the tempo data product for NO2. For formaldehyde, there's a question later on regarding formaldehyde, I believe. And for formaldehyde, the reason why we don't do the stratosphere troposphere separation is that the formaldehyde concentrations in the stratosphere are very low. So there's not really a need to do that stratosphere troposphere separation for the formaldehyde product, for example. And I think there's a question also related to ozone and the separation of that. Yeah, so the ozone is similar to NO2 in regards that we can get at information, or we do use a separation technique, right, to get at the stratospheric and the tropospheric concentrations for ozone, which are within the data product itself. Ozone is special in regards to we're able to retrieve additional information in the lower tropospheric layer. So we actually have you can get at the tropospheric or the lower tropospheric column amounts for ozone within the ozone profile product. And that might clear up those 3 or 4 questions related to troposphere for stratosphere. If I missed anything, let me know.
Thanks. And yeah, feel free if anybody has any follow-up questions, you can again put them in that Q&A box in the WebEx. Let's see. So we covered those. There's question number 5, which is just about the orbital period of the satellite. Again, we have that in the chat. This is a geostationary satellite, so it is constantly, the orbital period is 1 day. It's constantly staring at North America. And for more detail on that, we have some fundamentals of remote sensing self-paced training if you would like to get some more detail about the different orbital types. I see question 6 is about the lower signal to noise ratio with formaldehyde. Aaron, do you want to do that one now, or should we leave it for?
I kind of skipped over that one. Let's go back to that one. Maybe we can go to the following question.
Let's see. How about question 7? There was some a striping feature on the tropospheric profile that you showed. Do you want to talk a little bit about what causes that?
Yeah, so the ozone profile, I want to make it clear that we are still in the validation phase of that product. Like we mentioned in the training, it is a beta product right now. So we're undergoing pretty intense validation on that ozone profile product currently, with the hope that we can have a provisional ozone profile by the end of this year. So, but during our early validation results, and one of our main mechanisms for validating our tempo ozone profile product is the TollNet stations, which I'm not sure people know about TollNet, but it's a ground-based validation network for our tempo ozone profile. So our early validation results have shown that this horizontal striping is kind of similar to what we see with tropomi and OMI data, for example, in terms of insufficient calibration across the tempo wavelength spectrum, especially those wavelengths that are used for retrieving ozone information. So it's kind of similar to like the row anomalies that you see in the tropomi and OMI data that are also tied to calibration, um, calibration problems. And again, we hope to have much more information regarding this and also additional improvements in the product once we have that, once we have the provisional product available later on in 2026.
Sounds good. I think we're all looking forward to further validation and further improving of this product, but it's a really cool product. So question 8, how you can sort of reconstruct information about atmospheric processes or pollutant emissions during periods where the satellite is not making observations. The written response, I think, covers this. I don't know, Aaron, if you have anything to chime in, but essentially this is something that I don't think Tempo can't do it by itself. This is a case where you would bring in some other perhaps modeled data or other observations to be able to get the fuller picture there. And there's links to some other trainings which may be relevant to people interested in pursuing that question. I don't know if you have anything else to add, Aaron.
Nothing from my end. I think that response right there tells it all.
Sounds good. Yeah. So question 9, I think you touched on this already about how the data are calibrated with ground-based observation systems. You mentioned Pandora and you mentioned TollNet. And again, there was a whole training specifically to the ground networks that NASA uses to be able to get at air quality and climate applications. Let's see. So question 10, I think we already covered that. That's the tropospheric stratospheric division. Question 11 is a little bit different with converting the vertical column values into something that is like what is measured at the surface in ppb or ppm. And I think this again goes to, yeah, there's other information needs to be incorporated, something like models or something like ground-based sensors. I don't know, Aaron, if you have anything else to add to that.
Yeah, I think that is a great response right there. It just takes further work and further research to really get at that ppm or ppb value when you're looking at tempo data.
Yeah, that's always the $1 million question, is converting from the column values to something at the surface level. So question 12, I don't know, Aaron, if you want to elaborate a little bit more on this, but I think this is essentially talking about how can researchers best deal with places where there are a lot of clouds going on. And we talked about it with quality assurance. Tempo can't see through clouds, so you need to sort of filter with that. Anything else you want to add with how to deal with areas which are very cloudy?
Yeah, it's going to be a problem, right? I mean, when you're looking at cloud covered areas that are, cloud fraction, with the cloud cover is encompassing too much of the tempo footprint, right, where the tempo is trying to perform that retrieval, it's going to be very difficult to provide a high quality retrieval. So depending on what is meant by cloud noise, which I guess is just a tempo footprint that has a lot of cloud within it, that to really get, you really can't get high quality information on from tempo in those areas where the cloud fraction is high in the tempo footprint. So like we mentioned in the quality assurance discussion, even when doing a qualitative look at tempo data, we recommend filtering out any tempo footprint or tempo data that's tied or associated with the cloud fraction of greater than 50%. So that's probably at the level where this cloud noise would become a problem.
Yeah, one of the challenges in doing remote sensing observations is those darn clouds sometimes get in our way. So question 13 is asking about whether the AOD product is going to be in Worldview. It's not currently. We are planning to have a tempo aerosol product training later this year when those data are available more broadly. I don't know if we have any better timeline on that, but I think later this year is what I think we can confidently say, hopefully, that the AOD product will be available.
Yeah, looking at hopefully May-ish, potentially after, but yeah.
Hopefully May-ish, yes.
But that question, I should clarify here, the level 4 AOD product is really a level 4 PM 2.5 product. The AOD is actually a level 2 product.
Is there a level 2 and a level 3 AOD that will be?
No, so that is one difference between what we're generating for our aerosol products versus our trace gas products. So for our, as you saw on the table earlier and some of the presentation material, we provide the trace gas products on both the standard tempo footprint, but also on a standard grid, level 3 standard regular grid, which is referred to our level 3 product. We are not doing that for the aerosol. So we'll have the aerosols as a level, or the AOD as a level 2 product, and then additional retrieval processes are used to derive that level 4 PM 2.5 product.
Sounds good. Thanks for the clarification there. Question 14, yeah, I think that's an interesting question, but a little bit beyond the scope of what we are doing right here in terms of how solar radiation modification will affect these products. That's, I don't know that we have anything else to add beyond what's written on the screen right there, but it could be interesting. Question 15 about the validation of tropospheric ozone products. I think we covered this in detail and in some of in the presentation, some of the other Q&A. I don't know if we have anything else specific to add there, Aaron, but that's done with Tolnet and done with Pandora.
Yeah, again, like our Pandora network was really more for validating our total column of ozone product. The Tolnet program with the ozone profile retrievals from Tolnet are really the main validation mechanism for our tempo ozone profile. So yeah, we're more work to be done there, and we'll have much more results and progress by later on in 2026.
Sounds good. Question 16 talks just about the difference between geostationary orbit and polar orbiting. I think that was covered in the slides as well, and the fundamentals of remote sensing. I know we're at our ending time, but can we just perhaps, Aaron, if you want to end on question 17, which is when is the reprocessing for the version 4 going to be available? Do we have a timeline on that?
Man, I'd love to provide a timeline. We've been
Oh, it was
in
a bad
discussion
question.
with the Tempo team back and forth on this, and we don't really have a good timeline for when all that reprocessing will be done. But I will provide an email, and we will provide an email to all the Tempo folks, and on our various email chains, and email communication chains when that reprocessing is complete. But I hope, I'm going to throw it a ballpark. We hope by the middle of this year, it'll be all done and reprocessed, but I don't have a good timeline, unfortunately.
There's a lot of data to go back over, and there's yeah, it's want to be sure we're doing it right, and it can take some time to go back over hourly
But
data for years.
the key is we'll provide an email notification when that's done, so everybody will know if you're on our emails.
So sign up for the emails if you want to know exactly when that will happen. So I know we're at time. I think a couple more.
We can try to maybe address question 6. I was a bit, I guess the main thing with formaldehyde is just a challenging trace gas due, when you're trying to use a satellite to measure formaldehyde. It has a lower atmospheric composition compared to NO2, a much weaker, not much, but a weaker spectral signature compared to NO2, for example. We don't have that same sensitivity that we do with formaldehyde as NO2. But that being said, we have shown that our formaldehyde retrieval is good from Tempo, just not as good as our NO2 due to these challenging, these other challenging issues tied to formaldehyde in the troposphere. Hopefully that clears that up.
Okay. I know there were a couple more questions that came in. I don't know if we want to stay on or regardless, these will all be answered in this document and posted on the website. So question 18 is referring to question 13. Yeah, so PM 2.5, I think the link, I think we're asking for okay. I think the link to where the aerosol Tempo training will happen. I think if you sign up for the ARSET mailing list, the announcement will go out when we have dates on that. We don't have set dates for when the Tempo aerosol training will be happening at the moment, because we want to make sure the products are available at that point. But I think sign up for the mailing list and you'll be the first to know when the registration opens for that training.
Do you see that question 19 that came in there? If we want to address that or not, but
that one's all you. Do you have anything to add to that? Or do people need to do that?
No, they don't. I mean, right, like we mentioned in the training, we use the GeoCF model for this CTM and conversion of air and the generation of AMFs for our products. So, and the GeoCF is at a 1/4 degree resolution or grid spacing. So I'll just leave it at that. I mean, there are things that can be done with other models to bring in that may be higher resolution, right? But that is another, I guess, more intense training.
And I think for purposes of this training, probably you all on the back end, on the Tempo side of things, have already incorporated that. So I think what I would think is people don't need to worry about that, and you can use the products as they are and don't need to worry about that.
Yeah.
Okay. I think we might be at the end then. Thanks to everyone who attended, and hope to see everyone 2 days from now on Thursday, same time, or a few hours later. You can find the link on the website. There's 2 sessions each day. Thanks everyone for joining, and I'll see you next time.
Thank you.